All right, so for today what we're going to do is we're going to continue with exponential decay 8-6, but we're going to start working with real-world problems. And so we're going to scroll all the way down to this slide. We're going to review a little bit of yesterday. If you look at exponential growth, which is what we've done before, and exponential decay, you're going to notice that the equations are the same. Just like if we do a linear equation, y equals mx plus b. If my slope is negative or positive, and my b's are different numbers, it doesn't matter. It's still the same form. So you're going to notice that exponential growth is y equals ab to the x. A is generally a positive number. Sometimes it can be a negative number, but generally it's a positive number. And then if you'll notice, growth, our b is greater than 1. Okay, so it's always going to be greater than 1. But with decay, you'll notice that it is less than 1 but greater than 0. In other words, it's going to be a positive decimal or fraction. But it has to be less than 1. So it's going to be like 1/2, 3/4, 7/8, something like that. Okay. Now, if you remember, we worked with exponential growth before. And when we worked with growth, we had the equation y equals a 1 plus r over n to the nt power. Okay? You're going to notice that decay is very similar to this equation. What's one thing that's different about decay? There is no n. And if you remember with n, with growth, that was like semi-annually, annually, quarterly, daily. Okay, we don't have that with exponential decay. What else do you see that's different? That's correct. So growth, there's a plus sign. Decay, there is a subtraction symbol. Okay? So those are the two differences when you do these. Now, let's take a look at an example of the problem. So if you remember when we did word problems, the first thing that we were supposed to do is read the problem. So the population of a city decreased. When we see the word decreased, what does that tell me? That it's a decay. Okay? If it increased, that would be a growth. Okay? So I know it's a decay problem. And it decreased from 1995 to 2003 by 1.5% annually, meaning each year. In 1995, there were about 357,000 people living in the city. Write a function that models the city's population since 1995, then find the population in 2003. So this is a two-parter. The first thing they want me to do is to write a function. That's going to be part A. And then they want me to find the population, and that'll be part B. Very similar to growth, because we did this with growth. Right? So I'm going to write the equation. Here's A. Y equals A 1 plus R. I'm sorry, not plus, minus. Minus r to the t power. So y equals, what would I put in for A? 357,000, right? Right. So 357,000. 1 minus, what would I put in for r? So I'm going to use the percentage. It's going to be 0.015. I'm going to move it 2 decimal places. And then I'm going to go to the t power. That is your function. When you do your function and they're asking you for it, t could change. And that'll affect your y. It depends on how many years I'm looking at. So when they ask you for a function, make sure you leave the t as a variable and you leave your y as a variable. Does that make sense? We're okay? All right. Then part B, we're going to actually find out what that value is. So B, again, I'm going to use this same function. I did all that hard work. I'm going to use it now. And what am I going to put in for t? Yes.
8 years.
Where did you get 8 years from?
2003 minus 1995.
Very good. I got 2003 and 1995. So I take 2003 minus 1995, which is 8, and there's my 8. Okay, so we're going to take our calculators now. I'm going to walk you through how to enter it in the calculator. This is something you might have to practice. So I'm going to take 1. I'm going to subtract 0.015 equals 1 minus 0.015 equals. Okay, and then I'm going to hit the caret key or the exponent key. I'm going to put in 8. I'm going to hit equals. And then I'm going to multiply it by 3571000. And I get y equals 31634.2.8771. What would I put for my label? Yeah.
People.
Okay, so my label is people because I'm talking about the population. Don't write population, write people. Okay. Does my answer make sense?
No.
Why not?
You can't have point people.
I don't want point people, right? Yeah, that's gross. That'd be like a half a person or 3/4 of a person. That's not even 3/4. It's like taking your head off. That's gross, right? I want all of the person, right? So I'm going to change it to 4, 3 because the 8 right here is bigger than 5. So I'm going to erase this and I'm going to put a 3. And I'm done. So this is actually easier than growth. You just put in your percentage, and if you did growth, then you should be like, okay, this is cool. This is not hard at all. So today won't be hard at all for you. Okay, if you didn't do growth, this isn't as easy as you hope. So you want to make sure that you do growth, and then you want to go ahead and start decay. Questions? Okay, I think that's all we need to do for today. I have another example, but I think you're okay. I think this is pretty easy.